Okay, almost there. One more. This one says which system best represents what's happening. It's pretty simple. It's going to tell you which variable is what, and then it's going to say 4 tickets, 3 drinks, 5 popcorns is this. And so you literally just take the word ticket and change it into the variable T, and drink into variable D, and add them together and equal 85. I'll just let you write this one down. I hope it's pretty self-explanatory, where you're just taking what's happening, and you just got to make sure nothing gets mixed up. Like, I accidentally called this one 2 drinks, or something like that. Or they put the 4 tickets here and the 3 tickets here, and so it's 3, 3, and 5, and it's like, well, that's not quite the right one. So there's one out there that matches exactly. Solving systems, something like you can get 3 pizzas and 2 sodas for $41, and 5 pizzas and 4 sodas for $71. Well, this is kind of like what we just did, where 3p and 2s is 41, and 5p and 4s is 71. And so you get something like this. And we'll talk later, but solving systems, I mean, there's a bunch of other videos out there. If you want to do solving systems by substitution, this one's technically elimination, where we're going to multiply this row by -2 to where this 4s and -4s, I'm going to do it since I'm here, cancel out. I've eliminated this, and now I just have p to worry about. Negative p is -11, so positive p is positive 11. A pizza is $11. Well, if a pizza is $11, maybe that's what they're asking for. Maybe they asked for soda and said, well, I just got rid of soda. Well, let's just go back to 3 pizzas plus 2 sodas is 41. So 3 pizzas plus 2 sodas is 41. Since pizzas is 11, multiply, subtract, divide. A soda is $4. So it's, and another way to double check, well, if sodas are 4 and pizzas are 11, do 3 pizzas and 2 sodas make 41. 33 and 8 make 41. So yeah. Systems of linear inequalities. Man, this one's kind of weird because they like to use like a couple lines. Let's see, y equals, let's call it -x. But of course, they're using greater than, less than, greater than, equal to, less than, equal to. So what we're doing is we're looking for this green area, the numbers that actually work for both of these. So x equals 3 is this line right across here. Any x equals is a straight across line at, I'm so sorry, I'm going too fast. That is not x equals 3. It's y equals 3. That is a lot better. So y equals 3 is this right, up or down, whatever this number is. And y equals -x, it's just this. Maybe it's -2x, or it doesn't matter. You could graph both those and y equals and see which line's which. And then you go and say, okay, well, this is a solid line, and they are shading below it, which means this would have to be less than or equal to. Equal to because of the solid line, less than because of the shade below. This one is a dashed line, and everything above it is shaded. So this must be a greater than. And then you go find that, and maybe green is only thing that is shaded in, because honestly, that's the only one that works for both. Yellow worked for just one, blue worked for just one, but yellow and blue make green. So when they crossed over, they made green, and green's the only section that works for both. Which graph represents the solution? It's kind of the same thing, but you may have to solve both of these for y. Go back to some of the other concepts we've done, even in this unit. Get it to say y equals. Just make sure when you divide using a negative, it flips the sign. I actually did it on both of these. But y is less than this, so we're looking to shade under the green line, but y is greater than this, but over the blue line. And this little section right here is the only part that was under green and over blue. Because we could be above green and all that's wrong. We could be below blue and all that's wrong. So you just got to be careful. Please, 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 if you're this far into this, please be asking me questions and double checking answers. Switching from a matrix to a system, super easy. This is your X row, this is your Y row, this is your Z row, this is your answer row. Take those and change them into X, Y, Z equals something. I hope that's not too terribly difficult. You just got to make sure your signs are okay and nothing got swapped anywhere. It should be fairly easy. Find the value of Q, so the solution to the system is -3, 4. Well, it's pretty simple. If we're looking to have -3, 4 as one of our answers, it has to be on this line. So we're going to take -3 and plug it in for X, and 4 and plug it in for Y. Then just calculate and get 40. Q has to be 40 to even have this on that line at all. And then, of course, this will be part of this line too. We don't even have to worry about that top line. Parallel and perpendicular. This one actually may give you like a multiple answer one, so be careful because if you're perpendicular, you have your opposite reciprocal or negative reciprocal, whatever you want to call it, where 2 becomes -1/2. And we've already talked about this. These graphs touch only once. They cross at that one single point, and that is it. Parallel lines, they have the same slopes, and they should never touch and have no solutions. However, if these b values are the same, then even though the lines are parallel, they're technically actually the same line twice, and you could have infinite solutions. They don't call them really parallel lines, but for this, I think they do. I mean, they are parallel. They're just also the same line. So that one actually could maybe have 2 answers to it, so just be careful. This is the last one here, solving systems by addition. I really don't want to go into this too much. If you really need help solving systems by addition, jump on YouTube and find you a 5-minute video that just talks about this. But we kind of sort of touched on it where we're looking to eliminate something when we combine these together. So I can actually get these x's to eliminate if I multiply the entire top by 2. If I take the 3 and -7 that already have opposite signs and take this 3 across the bottom and 7 across the top, and I don't want to use -7 because then they'll both be -21. 3 and 7 is 21. 7 and 3 is -21. I need them to be opposites so they can cancel. So if they're already opposite signs, don't change the signs here. But if they are the same signs, then one of them, doesn't matter which one of them does need to be opposite. So this can say -42, this can say +42. And it doesn't always have to be y that cancels on these, the x canceled on these, the y's canceled. It doesn't matter one way. But again, if you're this far into it, hopefully you're asking a ton of questions. Please don't try and guess too much. We can work through these, and I can explain them a little better in person. But if you have these notes, hopefully it'll get you through a good chunk of this. Good luck on the pretest.